Okay, day 13. Let's get this done fast because I want to be done with it. And this is day 13. So that's day 12. Day 13. Climb the hill and again draw to the L's. However, instead receive a signal you weren't expecting, a distress signal. Hill device, packets got decoded out of order. You reorder. Your list consists of pairs of packets. Packets are separated by a blank line. You need to identify how many pairs of packets are in the right order. Okay, so packet data consists of lists and integers. Each list starts with that and contains 0 or more comma separated values. Each packet is always a list and appears its own line. Comparing two values, first line is called left. If both values are integers, the lower integer should come first. If the left integer is lower than the right integer, it is in the right order. If the left integer is higher, the inputs are not in the right order. Otherwise, the inputs are the same integer. If both values are lists, compare the first value of each list, the second value, and so on. If the left list runs out of items first, the inputs are the right order. The right list runs out of items first, the items are not in the right order. The lists are the same length, and no comparison makes a decision about order. Continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, and then retry the comparison. For example, if comparing 0, 0, 0, and 2, convert the right value to 2, and then the result is found using those rules in the right order. Compare 1 versus 1. That's the same. Compare 2, 3, 4 versus 4. Mixed types, convert right, and retry comparison. Left side is smaller. Compare that. 9 versus 8, 7, 6, mixed types left. 9 versus 8, right side is smaller, 7 is another order. 4, 4, 4, 4, 4, 4. Yes, compare 4 is 4, 4, 4. Input, left side round of items, so inputs are in the right order. Compare 7, 7, 7, 7. Right side round of items, left side round of items, so not in the order. Compare this, compare that versus right side round of items, inputs are not in the right order. For 8, compare this, 1 versus 1, compare that, 2, 3, 3 versus 3, 4, 4, 5, 7, 5, 7. The inputs of the pairs that are already in the right order. All right. So let us figure this out. Okay. And yeah. We can actually just use eval. Let me just make sure to call these the right things, pairs of packets. So let's say a packet is a list, and a pair is a tuple of packets. Def parse is a list of pairs, and split on double new lines. And let's say P1, P2 equals pair dot split on new line, and pairs dot append eval P1 and eval P2. Okay, so we'll use eval, and what doesn't it like? Maybe because I didn't put enough parentheses. Return pairs. List pair. Okay, and let's say pairs equals parse raw. So let's just run that and see. Okay, okay, and def compare P1 packets, which is 2, return, okay, are the packets in the right order? Okay, and so comparing two values. Okay, so we'll try and use match. P1, P2, okay, case int, I think that's right. The lower integer should come first. If P1 is less than P2, return true. If P1 is bigger than P2, return false. Else, the left integer is higher, right? Continue checking, okay? So let's just say, let's do this. 1 is good, return -1, which is bad, and otherwise return 0. Continue checking. So we'll have to do that. Okay. If exactly one value, so case int list, return compare of P1, P2, case list int, return compare of P1 and P2, okay, and then finally case list. I would like to do something more than that. If both values are list, if the right list runs out of items first, if the lists are the same length and no comparison makes decision about the order, and continue check the next part of the input. Exactly one value is the integer, convert the list to integers. If the last list runs out of items first, then the inputs are in the right order. So if P2 and not P1, that's good. The left one should run out of first, return 1. If P1 and not P2, return -1. Otherwise, both values will just compare the items of each. So let's do this. Compare the first value. If the list runs out of items first, if the right list runs out of items first, the same length, no comparison, continue checking the next part of the input. Let me see. 1 versus 1, 2 through 4 versus 4, 2 versus 4. Left side is smaller, so inputs are in the right order. Compare 9 versus 8, 7, 6, 9. Right side is smaller, so it's not in order. 4, 4, 4, 4. Left side round out of items. 7, 7, 7, 7. Right side round out of items. Let's say from itertools import zip longest. Okay, so if they're both lists for A, B, and zip longest, if A is none, so A is none means A ran out first. That's good. Otherwise, if B is none, B ran out first, return -1. Otherwise, if A is less than B, return 1. If A is greater than B, return -1. And then got to the end, and none of these happened, so let's return 0. Okay, and so let's try this. Okay, else that's what I think I want to do. Compare A and B. If result is not equal to 0, return result. Otherwise, I keep going. And I think that might be closer to what I want. Say these are in the right order. Usually these things so they overlap correctly, but pairs 2, so that's not in the right order. Okay, compare pairs 3, 1, that is the right order. Compare pairs 4, -1, not in the right order. Compare pairs 5, 1, in the right order. Compare pairs 6, -1, not in the right order. Compare pairs 7, -1, not in the right order. Okay, so that seems to be doing, it gives me the right result in the test case anyway. So def sum, def pairs of packets in the right order. Right order sum pairs, which is a list of pair, and is going to return an int. For I pair P2, and now they're starting theirs at 1. Result equals compare P1, P2. If result equals 1, res plus equals I plus 1, return res. Okay. I would rather write this as a list comprehension, but I'll just leave it. And assert that right order sum of pairs equals, and they said 13. So let us do that. That's right. Okay, so let's get our puzzle input. These windows are all in the wrong place. I don't know how that happened. It's extremely irritating. Okay, and now with open day13.text as f raw equals f.read, pairs equals parse raw, print right order sum pairs. So let's try it, and maybe it'll work, and maybe it won't work. 5292. 5292, 5292. Let's It is the right answer. Okay, good. Now you just need to put all the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. Using the same rules as before, organize all packets into the correct order. For the example above, the result of putting the packets in the correct order is that afterward locate the divider packets um, to find the decoder key and use from the indexes of the 2 divider packets. First packet is index 1, second packet is index 2. Divider packets. Organize all the packets in the correct order. Okay. So let's see if ChatGPT will let me in, or is it too busy? Might be too busy, which would be unfortunate. So I'd love to ask it. Okay, um, and I've been itching to do this as well. I need to sort a list in Python. I only have a pairwise comparison function. How do I do this? I mean, I can always BOGO sort using only pairwise. BOGO sort works on randomly shuffling. Oh, come on. What the fuck? This is the dumbest thing I've ever seen. Why would you tell me to do this? Um, be be serious. Give me a real sorting algorithm. Okay, give me the code to do merge sort. So you can see the real power of ChatGPT, assuming that this makes sense. Um, except that my my compare function is actually backwards. So uh, let me do shoot. So now I, I let me fix this. Return 0. What's going on here? Because instead I was doing correct, incorrect, and now I need to do that. Okay, good. So now I have that. Seriously? All right, ChatGPT, you fail. Python, sort a list using a comparison function. I know how to do it using a key, but um, does that work? Built-in sorted. Custom comparator should do that. Okay, that makes sense. Um, okay, this is what I need. Okay. I did not know about functools CMP to key. From functools, import CMP to key. Convert it. That's cool. How does, I'm actually curious about this. Functools CMP to key. This is interesting. Special key. Each element is compared with every other element of the list. Is it going to run it on everything though? Anyway, we'll try it and see if it's good enough. Okay, so let's go back to this problem now, and def find divider packets. Let's say pairs is a list of pairs um, and now what we said is we want to flatten. So packets equals P for pair in pairs for P in pair. And then let's say key equal comp to key of compare. Packets dot sort key equals key. Um, and let's say AB equals -1, -1 for I packet, or let me just do this. A equals packets dot index of locate the decoder key is 2 B equals packets dot index of 6, and then I'm going to do +1, which is a nuisance, and then return A times B. Assert find divider packets of pairs equals 140. 140. Okay, so let's try that and see if it works. 2 is not in the list. Oh, because I have to add those myself. Plus, so let's say P1 equals 2, P2 equals 6, plus P1, P2, packets index P1, packets index P2, and now let's try that one more time. And that did work. So print find divider packets of those pairs, and let's see if it runs fast enough. It does. It runs very fast because there's syntax error. 23868. That's the right answer. Okay, good. So that one actually wasn't as bad as it could have been. So what were the keys here? The keys here were, okay, parsing, we used eval, which is cheating. You should never use eval, but you know, this is a perfect time to use eval. Eval basically takes a string and evaluates it as a Python expression. This string is a Python expression, which is what we want it to be. And so we parse it. This comparison was just a matter of following their instructions. Again, a good use of match. I wrote this backwards the first time, but it turns out that like writing it as a compare function actually was the right thing to do. I just needed to do -1 for good and 1 for bad because that's that. And just following the instructions carefully with the recursion and the recursion and the recursion. So that was good enough. And then the other thing was, I know I meant to sort these things by this comparison. And so the interesting piece was this FuncTools CMP to key, which I've never actually heard of, but which Google told me about and ChatGPT didn't. So ChatGPT loses this round, Google wins this round. This CMP to key is actually it's an interesting little trick. I literally have never heard of it before, but I'm glad it exists because otherwise we would have had to do something painful. And yeah, that's that. So
Cool. That's that for day 13, and uh, I'll see you later.